Space around us is screaming electricity. This is something current science cannot hear at the moment, but it has become only a question of time. Eventually, it will have to open up to new ideas because a universe with 96% of unimaginable dark matter and energy is beyond absurd. Electricity as a force is 39 orders of magnitude stronger than gravity. Everywhere in space, also on the planets of our solar system, signs of its action can be seen. Plasma is a prominent state of matter. But what about Earth itself? Is it really the isolated neutral rock in space? Is its surface only touched by wind, rain, ice, erosion, volcanism, plate tectonics? Or does electricity play a role here too, that goes far beyond the occasional lightning? Catastrophism has found its way back into the description of Earth's past during the last 30 years. The electrical force adds a completely new level of catastrophic possibilities to the equation. The tool set of geology can be greatly expanded, keeping electricity and plasma in mind. The photographer Michael Steinbacher is out in the field, trying to make sense of the geology he sees with the background of plasma cosmology and catastrophism. Follow him and a group of independent researchers on their journey to reinvent Earth's geology with electrical eyes.
It's similar to the smaller one we saw down below. We're okay, folks. Okay, let's go through. We've got permission to go here. Let's go here.
We do?
Yeah.
Okay.
This is the very beginning of the process. This is conglomerate, and that gray area where you can see the stratification is close to becoming granite. I don't think it is. The rest of the area is conglomerate, dirt, matrix, and very large rocks. But it's been removed. It's different than the rest of the area. Something went in and removed material, probably similar to electric discharge machining, or even wind, but it seems to have heated it. The next canyon over is more confined, and it's made it all the way to weathered granite. It's really wonderful. It's so easy to see.
I don't see it.
Now we're getting into bigger chunks where the finer stuff has been washed out. It looks to me, with my orthodox background, that this is just where the water erosion has stopped, and each rain erodes back a little farther into the loose, conglomerate on the hillside. The orthodox explanation has never taken into account the Earth's electric field. So we're standing here in stuff that looks like what it looks like, and then we try to interpret it. I think of water and water erosion, but I'm standing in the middle of 100 volts per meter, and it's an open question as to what effect, if any, that has on this.
During that sedimentation
process. The original consistency is open to question. With Michael's idea, this would have been the original consistency that would have had, it wouldn't have been completely suspended in water, it had just been wet. So it would have had high viscosity compared to clear water.
More like wet concrete mix as opposed to dry concrete mix, or let's say
yeah, that's why he calls it a slurry. It'd be like soupy concrete.
Yeah, but
like shale, or slate is metamorphic shale, one of the others.
Right.
You start with something that's like sandstone, and then you compress it.
How is that
becomes
different?
granite.
So how does that differ in metamorphic terms than what we see going on here?
It's totally metamorphic. metamorphic.
But so it is.
This is electrical metamorphosis.
Yes. But so it is metamorphic.
Absolutely.
Okay.
Yeah,
There
this
you go.
started out as one thing.
Yeah.
It metamorphed, change shape.
Change conditions.
Yeah,
change features, change quality.
Yeah, metamorph in shape.
Right.
Yeah.
Metamorph. Yes.
Yeah.
So we were in agreement. I thought maybe we weren't. But, yeah.
So yeah, this is metamorphic because this isn't how it started its life, right? It's now turned into something.
And it's sedimented.
In this particular case, look at this.
Hold on. Yeah. Yeah, that's it. I'm seeing that marble everywhere. This thing.
Yeah,
it's everywhere.
Would you expect that from
We
typical
never saw. We didn't see veins.
water-based sediment?
We didn't see. No.
No.
No,
Yeah.
no,
Actually.
back up the truck. That's why he showed us before and after. That's before metamorphosis. This is after. This vein was formed as part of the process.
Right.
Yes.
Right. Because the layering.
We saw
squeezed.
no such.
I think it is a specific layer.
We saw no such features
Double layer,
there. I
I
didn't.
think.
We saw it in the loose rocks everywhere, but
Yeah.
not in the conglomerate like
Do you
this.
suspect that it may have been something similar to the double layer present during the
Absolutely.
liquefaction?
That could be part of the sedimentation
Yes.
process. Absolutely.
If granite is external, it changes most of the way people think about geology. It's a whole new animal. I was in Colorado at 8,000 feet at a gas station, and I met a gentleman who was trying to do smelting. He tried to get silver and gold out of ore that had no crystals, and he failed miserably. But what he produced between the two electrodes is a piece of rock that seems to be metamorphic. And there's crystals in it. And there were no crystals to start with. An arc from a welding generator seems to have created man-made metamorphic rock. This changes everything. As it turns out, NASA has sent satellites to comets. And they collected dust and brought it back. And there were huge surprises. The dust contains limestone and dolomite. Dolomite can't be explained as occurring on the Earth. It doesn't. Geologists think that limestone morphs into dolomite by magnesium being injected. But chemists say that's impossible. It won't happen on the Earth with the conditions we have today. But there's dolomite and limestone and comet dust. The wind and the dust would blow across oceans. With nothing to interrupt the wind, the dust would not land. If the dust was external, not from the Earth, but from the tail of a comet, which was Velikovsky's thesis, as it blew across the ocean, it would get thicker and thicker, not landing and coming down all the way across the ocean. He felt the winds were from the west, so they would blow across the Pacific Ocean. The first obstacle would cause a dune. That's like a snow fence, a snow drift. Because the dust had been accumulating for such a large distance, the first obstacle would be the biggest mountains or dunes. So if you go from Alaska to Chile, on the west coast of the Americas, you'll find the biggest mountains. If you go to the west coast of just about any island or landmass, you find the largest mountains. After a number of days, it changed from a west wind to an east wind. But there wasn't as much dust. So if you go to the east coast of land masses, you find large dune mountains from my perspective.
It gets more and more and more. Down here further away, you see smaller dunes that are in. They have a less of an angle.
Oh, the little ones, the little baby ones. Oh yeah. The end of the process
That's the
where it's
sperm of
running
the
out
egg.
of
This
sand.
is the embryo.
You can see how it runs out of sand. You can see how you get one mountain chained next to another, just like the way the mountains are.
Yeah.
And then it rains here occasionally, I guess, and that enhances the sculpting
Have you
of the
been
valleys.
actually been out to? You haven't been out there, I'm sure. Right.
No, but I've been to ones much bigger than
Right,
this. Sandy
right.
National Monument puts these to shame. And then the ones in Death Valley are smaller than this, but those are the ones that I saw with mountains behind them that got the ball rolling.
These are dunes outside of Palm Springs. They're known as sand dunes. You can see it's sand. You might see a relationship between the dune and the mountain behind it.
we're on top of a beautiful sand dune, downwind from a drainage. It's probably not the modern drainage of today that caused this, because it's so big compared to other dunes that should even be bigger than this, but aren't. It's really a simple dune, except in locations, there's areas that are removed. And on those areas, there are huge boulders, and they seem burnt. And they go up the canyon where it gets pinched to the greatest point, and there seems to be material removed in a vertical process, similar to what we've been seeing in places with really high current. So this to me is the minimum amount that removes the side, creates rocks that really shouldn't be there in a dune. They wouldn't get blown in here under normal circumstances, only catastrophic circumstances. And something remove one side and not the other, and if it was water, it should be equal on both sides, with the water coming out doing the same thing to one side as the other. Only something directional can take one side of a canyon, and you see it everywhere, that one side of a canyon is zapped and the other's not, or one side of a ridge is zapped and it's not. Something is flowing over it. And if it's in opposition, zap. If it's not in opposition, it goes over. It's so simple.
The plasma came up here, and Birkeland current just right along here and just removed stuff. Tossed it out, threw it out, picked it up, levitated it, and took it somewhere else.
Probably fine dust being created
Fine
during this
dust, yeah,
process.
ground
Almost
it up.
atomic sized dust, according to EDM reports I've heard.
Yes, picked it up and chewed it up into fine dust and just took it downwind.
In the end of the canyon, it's both sides. But coming up
Okay,
here,
yeah,
when
because
it's not as
it
pinched.
gets narrow.
Yes, where down
probably
there
more
it might be
pronounced
both
down there.
sides. But this side, it wasn't as strong, or it's directionally preferential over on the south side, not the north side. And water doesn't fit the bill. Only electricity would do something like this. So what's nice about this, it's minimal. It's not so much that you lose sight of it. You can see where it's just starting. And it makes your roller coasters like a router took off that stuff. It's not following the drainage, that removal. And that's the key.
Down.
That's how you can tell the difference. It's a roller coaster.
Exactly.
So named.
You can see that it was conglomerate to start with, and something turned this into what is considered weathered granite. I've shown it to geologists, and they all seem to agree, weathered granite. This doesn't fit any of the normal models of how things happen like this.
Okay, here there's a ridge. There's rotten stuff underneath. Rotten stuff. And on top is a layer of good solid rock.
Yeah, absolutely. Or it's on the surface. But this is that dirt.
And
that's the key to me.
further up here
That turned into this, just like
is more rock. That's nice solid rock.
external granite. And this should be on the top. If it's weathering.
And
It shouldn't be underneath.
it could fall down
That's what got Scott.
over there
I was loving it.
onto the road.
Oh, wow. When he saw that, wait a minute, the weather stuff is underneath of the really hard stuff. It should be reversed.
Exactly. And that rock fell without crumbling.
Scott, you had a unique thought.
Excellent.
How did that feel?
Felt great.
It's like tingly.
Oh yeah.
You're the first person that ever saw this.
Yeah. And thought that
Doesn't make any
is
sense.
backwards.
Have a better look here.
Excuse me, ass backwards.
Okay, if you like.
Really visible.
Okay. Okay, sorry about that.
And I'll bet you there's layering down there that'll
Yeah.
mimic this layering.
So this here is basically really
Rotten.
That's rotten stuff. Rotten granite. It's got the same texture as
You're breaking
granite.
it off. You're breaking chunks off.
Yeah. Try and break a chunk of that off that other rock. That rock up top. See how far you'll get.
No.
Yeah.
But one of them fell down here. It looks like
Yeah.
covered by the
And then
the hardwood.
there's another one right there, right by your foot.
Yeah. Or even
There's
up higher
that.
than
There's a bigger one there too. Right where my shadow ends.
this one here.
There's one over there.
Exactly. It's not the rotten. That's the
Yeah, that's the good stuff.
fell down from above.
Yeah.
Compared to
Yeah.
you can break apart with your fingers.
Yeah. Yeah, so the stuff that's on top, and this I think was carved away by the road, wasn't it?
Yeah. It was a road cut.
This is a road cut. And
Exposing the
exposing
stuff underneath.
the weathered
It's
rock.
not available for weathering.
Yeah. And the stuff that's on top, that's weathered, isn't weathered.
It's hard as a rock and is
Yeah.
not weathered at all.
Exactly. Well put.
Yeah.
Okay, and there's the ridge up there. A bigger ridge with a lot more rocks that look solid.
Yeah.
Way, when the process gets hot enough, it seems to melt the material. When the material melts, I've been told that the surface tension would increase, so it would be more difficult for the electricity to remove it because it's a liquid. It's easier to make a dust storm out of solids than it would be a liquid. So as you cease to make dust, the process of liquefaction would increase. It would get hotter and hotter, and you get more and more rock. That seems to be a pattern which repeats itself over and over, everywhere I've been. The dust is removed. As it gets hotter, you get granite, and if it gets hotter still, you can get metamorphic granite because it's being affected electrically, and it's misconstrued as depth, heating and squeezing, when in an electric universe, you don't need depth. There are garnets in the Himalayas that, according to geologists, start at the surface. In order to be converted to a garnet, it has to go down 120 miles to be heated and squeezed, and then miraculously, it has to come back up again. And then you find them sticking out of the surface. What are the odds of it coming up 120 miles to the surface? But in an electric universe with dust in the air, they'd be naturally produced this way. Here's a canyon in Death Valley. It's Marble Canyon. It appears that the limestone, actually dolomite, flowed down the canyon.
Dolomitic marble on the base of the canyon when there's no gravel.
Oh.
Where the gravel's washed away,
Yeah. Yeah,
the whole thing
yeah.
is dolomitic marble.
Yeah.
Gravel came down later
Yeah,
and filled in places.
Yeah.
But the bottom of the
Yeah.
thing is dolomite.
Yeah.
Slippery. Dolomite.
Yeah. Seems what?
This, they assume there's dolomite under here.
Okay, yeah.
Like that.
Yeah.
This stuff
That's
came
how the marble
down
came in.
on both sides,
Yeah.
filled it up to that depth,
Yeah.
and then water washed it all away.
Yeah.
Slurry runoff is very high, all the way up to the top of this formation that's horizontal. Logic would seem to dictate that that was all the way across, and water came through later and washed everything that's not remaining away. And at the ridge, next to where the very slender canyon is, the current wanted to come up here, but there was only so much room in the slot canyon. The plasma would back up, kind of like water, and then come over that ridge, burning it right where the low point is, where it would be most likely to slosh over. Kind of like water, but plasma that's hot, able to burn that formation. Yeah. It is aurora-like. Not necessarily the aurora, but think of the aurora. A flowing river of fire, with filaments zapping some places more than others. This is, it couldn't have sloshed down and made that, or sloshed down and made that. That has to be a dune. You agree? It's against the direction of the flow. So only dune.
In here it is quite interesting.
And all of these are trending this way, as if something came from up the valley and filled that in. It does not look particularly lithified either because it's so wide. And the narrowness is the key. I'm glad you guys got to see the narrow thing. And the concentration of the plasma raising the current. According to Mill. I didn't come up with something like that. That's over my head.
Here's a mountain outside of Death Valley. Instead of slurry runoff, to me this appears to be a dune growing from left to right. Those would be the angles that you'd expect from a dune. It's hard to see how that would be produced any other way with that pattern. That's a dune pattern. Don't go there in the summertime, by the way.
some very obvious duning angle here. Slip face to the right.
Yes.
The whole thing has slip faces to the right, if you look. The entire formation. The wind was blowing this way for that mountain. Different than the basalt, the opposite of the basalt. You see what I'm talking about? The flat angles,
okay. Yeah.
they're slip
They're
faces.
coming down this way.
All of them.
And the other ones are
All
going
the
that
way along.
Okay.
Wind's blowing this way, blows along, goes down because it's a wind block.
Okay. Yeah, so it's the slip faces on the right side.
I believe so.
Okay.
Because it blows up
And
the
goes up that
lesser
way.
angle,
Right.
and it comes down the sharp angle. And because it's not silicon dioxide, it can maintain that very, very steep angle. It's maybe 50 degrees,
Okay.
which sand would not support, but conglomerate would.
Okay.
And then
And this
we
one,
can go
is
places
it,
where we'll see granite that's obviously consisting of conglomerate that
Okay.
got zapped. So you can still see it in the stuff if it's not melted
Okay.
too much.
So this one's straight ahead.
Of old age when it takes you longer to piss than it does to shit.
Wow, we should record that.
We just did. Words of wisdom for future generations.
Yes. No, what were you saying?
The one straight ahead. Is
Yeah.
it still the same slip face?
Could be. Looks like it, doesn't it? Looks like it was growing this way.
Yeah.
With slip faces.
Yeah. And the one to the next, the one over there.
And it might have been wet. And it's
Okay.
growing, filling in the water.
Yeah.
This was underwater originally. And it grew
right
this
to
way
the,
and filled it in, and then it runs off, making an alluvial fan. And sloshing can also do that, but you have each one of those little valleys has water washing
flowing
out dust.
through. And, yeah, wiping the stuff clean.
Filling in the valley. And then if the valley gets filled in and there's a slosh, it all gets pushed back up and runs back off again with lots of current, making that distinctive sedimentation, horizontal layering, basically.
This is a Virgin River basin. Here, Michael Steinbacher noticed the process of rapid horizontal stratification for the first time after understanding the stratigraphy videos from sedimentology.fr. Imagine the whole basin being filled with this kind of sediments, which were created fast, when all this land was underwater. Then, as the water levels subsided, the strong current eroded the fresh sediment away, like a hot knife through butter. Later, an electrical event lithified the remaining sediments and created the stone mesas that we see today.
Yep, it looks like they might be fairly serious. Another guard shack.
Yeah. As if being on the edge of the cliff isn't high enough.
Now, people might be rappelling up this. Rappelling up? I don't know if you can rappel up.
If there's a vortex.
So this is where it hit me. All that stuff. Like dirt. It's sort of like cement as opposed to being molten. I don't think it was melted. It's as if there's carbonates in here and it set it up as rock. There's also blue rocks all over the ground. They're just everywhere. I think we might borrow some of these.
Oh man, this is tender stuff.
We'll bring the blue back, but we're going to borrow it and take it with us for
Just a
now.
moment.
Look, it's just dirt.
Yeah, some of it's dirt, some of it's sort of cement type dirt, and yeah, different amounts of lithification or non-lithification. Is non-lithification a word?
Probably not.
I don't think so. If I
Use
use
it in a
it,
dictionary, you can't make it up.
It appears that the currents come up a canyon. As the canyon gets more narrow, the current's compressed. As it's compressed, it seems as if the energy goes up. So you see more and more damage as you go up the canyon. When you get to the pass and you go over the other side, it's grass. It's dirt with grass and usually cattle. And then you get to the next, usually south-facing side, and you find more rock. And then you get to the ridge, the On the other side, it's grass. And this goes on for over 100 miles in the Book Cliffs. You see this almost everywhere you go. The south side of formations are melted, turned into granite, basalt. The north sides of formations are not melted. They look like dunes. The south sides have lost their dune shape because they've been melted. If the process gets very intense, you wind up with basalt. According to Worlds in Collision, the mountains melted. They melted like wax. That's a description of electricity taking a peak. And just like a snowdrift in the spring, it would relax as it's heated. And you find 250-foot thick layers of basalt on tops of mountains, over and over. I'd go to the BLM office, Bureau of Land Management. There's always a geologist. I'd say, what is the black stuff? I'd say basalt. So where did it come from? Well, there's a volcano 80 miles away. And I asked for directions, and they say, well, there's no volcano there today. It's eroded away completely. But we know it was there because there was basalt. And in between the missing volcano and the basalt feature, there's all this missing basalt because it had to flow. But it's not there. And downstream, no basalt. So it appears the basalt was formed in place over and over. You don't need a volcano to melt a rock in an electric universe. All you need is a river of fire.
It's just
No, it goes straight. It's the same rock.
It might be basalt, though. It can be a different color and still be basalt.
But it didn't land. It's this rock fried. I mean, look, it's the same rock. It's just been fried on top.
Is it dirt? Is it lithified?
It's totally rock.
Yeah, okay. It's probably basalt. The outside stuff is burned.
This is burnt basalt.
There you go.
Absolutely fried.
And it can melt.
It's melted. It is.
And it can run downhill.
It's melted.
And everybody will say it's a basalt flow from a volcano.
Here's a part where it
Although there can be basalt flows.
Here's a part where it chipped off and then froze back into place.
It's having so much fun.
All right.
Actually, Mel and I did this in Oregon.
I mean, there's no...
At the Columbia River Gorge.
Same thing?
Oh, exactly the same thing. His first trip out. And we didn't have as much stuff for background.
Somebody chipped the top of this one off, and you can see where it's transitioning. It's the same rock. It's just been fried.
It makes it
sat.
It's almost like they did it for us to make it easier to see.
Just peeled that off, yeah.
And it got fried, I think, that this crater. I'm not sure now. I'm taking a flyer.
Yeah, we should brought
I'm guessing that crater had something to do with this.
Just think.
That's just
possible
by chance there.
Really?
This is a lava flow from that volcano over there, because you can see how it all came this way.
The disappeared volcano.
And then it was eroded.
Yeah.
The black is just painted on it.
Oh, it's paint.
It's a hoax. Damn it. Wow, he anti-hoaxed it.
It's a spray job.
It's a spray. It obviously sprayed because, you know, it's directional. These holes don't.
This is the happiest day of your life.
Oh, and they busted it off. You can see the goodie.
I don't think anybody busted it off.
I think it just fell off.
Although you don't have a lot of ice here, which is what causes most of the erosion.
Yeah.
Without ice
it's
expanding, what we're looking at is the end of the process. This is the way it looked the day after this happened.
This thing
There's
sounds
no
like
time for erosion.
Yeah.
Zero.
a piece of ceramic or something when you pound on it.
It really does.
Yeah.
Well, it has holes in
You
it.
hear that?
It's hollow.
Yeah.
It has holes in it.
Yeah.
It's quite bubbly.
Now you see, this was deep underground.
This is all plastic,
When it came up, the gases that were in there were released.
This is not
That's
painted.
why the holes are there.
This is not painted. This sounds like plastic.
Oh no, it's getting worse.
Is it like the one in the BLM office?
Yeah.
Yes, exactly the same thing. Amazing.
It's harmonics. You hear the harmonics?
Yeah.
Well, see, you can see all the erosion that's been going on here also,
You got to read about it.
which puts the eroding basalt into perspective. How much erosion is here and how much erosion is called for the mainstream version.
Yeah, exactly.
This is so fresh, and they always talk about that.
Yeah.
That what's remaining is so pristine.
Yes.
And then you have 60 miles of missing 1,000-foot basalt, I would think, at the vent.
Now,
To be 250,
Yes.
60 miles away.
look at this.
This ought to be good.
The rock, and here it's light colored. Here it's gray.
Yeah.
And
And
then
this
you've got this
stuff
filigree. No,
That's
down here.
cement.
You got this filigree of white stuff
Oh, it's
around the
layered.
edge, and then black is on top of that.
Mm-hmm.
So what's
It's coming in layers. As the
there's some-
current is spinning the dust, it's also separating it. So
no,
one
I don't
side
think
is
that's a
going to be
layer. I
X
think
and one
that's a
side.
that's a
There's some
some
stuff over here,
chemical.
too.
Yeah, okay, I'm open to that.
has
Excusez-moi.
been- Well, because it's not
Has been pushed out
it's
of the
not
burnt,
even.
pushed out and infused into the virgin
Well,
rock?
or as it
You have-
cooled, or
you
as
have
it
to
was
remember it's
burning,
happening in
or
layers.
as it was
Separation,
melting.
some kind of
Sometime during the process, there was a chemical separation.
Yeah.
Because here it's scattered all through here.
If it was coming,
Here it's a layer almost at the edge, and here it's scattered out through. And then the black is a thin layer on top.
Yeah, I think something from the black diffused into the brown, which is hot too, but it
Okay.
wasn't enough to
it was here as basalt, like it is underneath, and then it got zapped, and this process on the surface took place.
Could be.
I'm guessing from
Yeah.
your description. It would be a post application, possibly 5 minutes later, or whatever, that would have done concentrating and sorting.
I thought we could go
electrical.
up to the cone.
Some half circular. Two rings in here.
This is the Black Canyon of the Gunnison. I believe this is slurry runoff that came from mountains to the east. The river at the bottom would be able to carve its way through fresh sediment very easily. It appears that something came through afterwards and electrified it and turned it into rock with massive layers of quartz. It's an interesting place. This process was really dynamic, and it was wet. There was lots of rain. There was sloshing of oceans because the earth was changing its motions, which would cause the water to move, but not a tidal wave, a slosh. An entire ocean would wash across the landmass and then drain out.
The Grand Canyon is unique in that it has the Colorado River running through the middle of it. Not the middle, but the river dissects the mountain that surrounds the Grand Canyon. At the base, you have schist and granite that must have been a dune to start with that got zapped, and then you have sloshing because the Colorado, being in the neighborhood, is going to make a flood every time there's any sort of a slosh. So each time there's a slosh, you're going to have water running over the mountains that surround the Grand Canyon, adding to the depth of the sediment in a slurry runoff process. The water went down. There's a dune layer of sand dune with burrows of animals digging into the dune to make a living. That is one of the layers. Then it got sloshed again, and there's layers of sediment on top of that. That's part of the slosh. So it's a sandwich of sloshing and duning and sloshing because it's right next to the drainage area. It's always going to be wet there when these events take place. The canyon might fill up with soft, wet sediment during the sloshing, but as the water level goes down, as it goes down from 6,400 feet to what we experience today, you're going to go from a lake, an inland sea with very little current, to a raging river, the width of the canyon, not just the width of the river today, but the entire canyon would be full of water going south, downhill, real fast, and it would just clean out the canyon of sediment that had formed instantly. And the only thing left at the bottom of the canyon are boulders so big that the current can't wash them away. So It's a really simple process, just like all the other canyons. They're not eroded, they're prevented. The water prevents accumulation while the areas that are next to it accumulate. It's really simple. And then you can see the layers, the sedimentology videos and the experiments in stratigraphy show you the process. It's fairly easy to see. And the fact that you can see the layers so clearly on photographs makes it easy to embrace, I think. So it's a different way of looking at it. The canyon was never full of rock. It might have been full of soft dirt, but you can flush that away in an afternoon.
Dr. Velikovsky wrote of these things in Worlds in Collision. There's basically wind and dust, flood, and a river of fire. All you need is a river of fire, as described by the people who survived these things. Every culture on the planet refers to these same events, especially Egyptians. They confirm the Hebrew version. If it was just Hebrew, I'd ignore it. But it's Japan, China, India, Scandinavia, Peru, Mexico, Oklahoma. They all tell the same story with the same details. It seems as if what's described in Worlds in Collision is confirmed by what's found on the surface of the Earth. And what's described in Worlds in Collision is nuts. It's just so different than what we experience. But what you see on the surface of the Earth is nuts. They fit together really nicely. And they tell a story that's completely different than what's taught in every geology class. The geologists and I seem to agree, or they help me understand what's inside of formations. But their explanation of the process is different than everything I think. There's no common ground whatsoever. I wish there was. It would be so much easier to get them on my side. But everything they say is so complicated. It's just, it stretches your ability to think about it. When I go to state parks and national parks, I hear the explanations, and it never made sense. This is simple.